Welcome everyone. My name is Amparo Lopez and I am professor at Polytechnic University of Valencia in the Hydraulic and Environmental Engineering department. Today we will be speaking about the appropriate pump selection for operating conditions in hydraulic pumps. When we finish, we will be able to properly understand the principles of hydraulic pumps selections and to know the important curves in this selection and the important point in the operation of the pump. We will be speaking about the curves, the points, and some other aspects like the number of specific speed in a pump, which is very important for pump selection, and finally the selection procedure of pumps. As we know, pumps are hydraulic transformers. They get energy from mechanical energy from a shaft and they give it to water or any other fluid in terms of heat and flow. Therefore, to select a family of pumps, we must know this sort of curves relating, in this case, the flow with the head, and a family of pumps, depending on the diameter of the impeller, can be used to choose for a particular point. These curves represent the performance of this pump across the characteristic curves. In this case, the operation points relate the needs of the facility in which we install the pump, which has a head to pump and then all the losses in this parabolic increasing curve, and the main curve of the flow versus head, which we have here. The point in which they cross is the operating point. The operating point needs power related to the performance of the pump. So the operating point to be known needs the rest of curves. The curves of a machine relate the flow with the head, the flow with the NPSH, which are the cavitation curves, and the flow with the power relating with the performance of the machine, indicating us in which point we should be operating. To know this point, we should know the performance curve. This is the performance curve relating the performance with the flow. And in this case, this point in which the performance is the best efficient point. The best efficient point should be the point chosen for operation in a pump. But in general, this is not the point in which pumps operates, because as we said, operational point depends on the set curve of the facility. So what we should do is to choose a pump in which the most of the time we will be near to the operation of the best efficient point. Like in this case, we will be choosing a pump which most of the time will be in its best efficient point, which is a good choice for operation. We have more other parameters to choose a pump. For example, the number of specific speed in the pump. This number is a dimensional number, which we can be found here, which is related directly with the morphology of the pump. The morphology of this pump in its best efficient point indicates as is the pump will be very vertical in its curve, which is a multicellular pump, or very horizontal in this curve, which be an axial pump. We will be relating the number of specific with this best efficient point, and we will have an idea of how to begin our choosing. The number of specific speed will give us some idea about the morphology of the pump, and the operational point in this diagram relating a family, several families of curves, will be indicating us which is the most interesting point to choose for a particular operational point. So in this learning object, we have known about the relating between morphological conditions, best efficient point, and operational curves to choose a particular pump. The choosing of these pumps should consider the most efficient pumping in the system, the point in which the pump is giving us the best efficient point related to the operational point, to have the most of the time this operational situation in the system, in the facility, to get the more efficient energetic system as we could choose. I hope this has been interesting for you. Thank you very much indeed.